So our next speaker is Ed McNamara, and just to give you, for those of you who don't know Ed, he is how would you say, he has his own company, own development company, and it's called Turtle Island Development. Ed's been in the area for quite a while, and Ed and I met back in 1997, I think. And Ed had a problem on a project he was working on, and somebody said, why don't you call Tom? And so we made a connection and then found a solution to his problem, and then we started talking about green ideas, and I hope you don't mind if I take a moment just to sort of give you this story. And so I, at the time, was still talking about Ecoroof and trying to get anybody to listen to me, and I had mentioned it to Ed a couple times, and he said, thank you, Tom, you're a nice guy. But I got to get on to my work. And he was working with a development company at the time. Anyway, so one day after, gosh, we must have known each other about 2 years, he called and he said, well, I've got another project, and I think I want to see if we can do an Ecoroof on this project. And of course, I was, I was very calm, but when I hung up at the phone, I was just running down the aisles at the bureau and trying to talk to anybody that would listen and say, hey, we've got our first project. And I actually ran into Dean Marriott, who is the director, and it was a very coincidental thing because Dean had said to me, we're meeting each other in the hall, and he said, Tom, did you hear about the project? And I'm just going, yeah, I just got off the phone with Ed. And he goes, Ed? I said, yeah, Ed McNamara. He goes, well, that's not the project I'm talking about. I'm talking about the project at the Hamilton building. Ed's was the Buckman Terrace building. So it turned out that on that same day, we had our first two projects, and Dean and I were both talking about two different projects and then realized that's what we ended up with. On the same day, two different developers had said they didn't say they were going to do it. They said they wanted to start working toward looking at the feasibility of doing it. So Ed is a real pioneer and innovator and very practical man. So I'd like you to please help me welcome Ed McNamara.
I think Tom meant practical as a compliment. I'm pretty sure that he did. And Tom was really pretty gentle. The first time I called Tom up on the Pearl Court Apartments, we were trying to do what, I don't know if there was even a name for it then, but green building, and we were getting our first endangered species listing on fish in the Willamette River. And I said to the two people I was working with as my kind of what we called them, I don't know what we called them, green building consultants, I said, shouldn't we be doing something about the stormwater? I mean, we're killing the fish. And they went, oh, yeah. Why don't you call up this guy, Tom Lipton at the city? Tom showed up, and I said, Tom, let's, I want to see if we can do something about stormwater here. He said, you want to do an Ecoroof? I said, well, that's an Ecoroof. Well, you put all the water on the roof. It's like, no, that's exactly what we don't do in my business. But so when I called Tom up on the Buckman thing, the first thing, I actually didn't say I wanted to do an Ecoroof. I said I want to do something with stormwater, and I knew we had to start very early. And Tom said, you want to do an Ecoroof? And I said, well, Tom, it's going to have a sloped roof, so it just won't work. He said, well, we can do those. Oh, man. But we wound up doing a little Ecoroof on the second building over there. But mostly we wound up doing some really incredibly innovative infiltration swales at Buckman Heights and infiltration trenches at Buckman Terrace, and they worked amazingly well. So it's been fun to work with Tom all these years and finally do a full-blown Ecoroof, and that's what I'm going to talk about today. So first thing, even though I've been playing around with this for a long time, I'm not an expert in any technical sense of the word, so take all this with a grain of salt. Maybe what you'll get out of this is that if you're a designer or an architect or an installer or supplier that has to deal with developers, I'm the kind of idiot that you have to deal with to make these decisions. So I'm going to share with you some of our thinking so you realize how to work with us. So I guess one, I threw in a few photos because these things can be deadly boring. Some of them are gratuitous, but this one actually had a little purpose. What I'm going to tell you is that this is a wood frame building. It's unusual that it's all brick, and that was a relatively new thing under the IBC that we were able to do. This first level here is the concrete podium, and then there's 5 stories of wood frame construction. Up until a couple years ago, you couldn't put brick all the way up because you could only support the brick off of that concrete and go about 30 feet. Under the IBC, we could take it all the way to top, but we hang it actually off the wood frame at each floor. There's a ledger there. So we're putting an awful lot of weight on the structure. And I'm telling you that because it's going to be important later in my talk. And then, so I'm going to go through three things here. Just a little summary of the building and the agonizing decision process we made about putting the Ecoroof on. We actually looked at it once, rejected it, looked at it a second time because of Tom calling me, rejected it again, looked at it a third time because of Tom calling me, and this time we decided to do it. And so then I'll tell you how we went through that and why we rejected it and why we finally made it work. And then I'll just show you a little bit of the roof, throw in some more photos because it's more interesting. If you haven't seen all the details, we'll give you a little slideshow of what really happened. So, these are gratuitous photos. That's the entry of the building, and that's looking down on the courtyard. Actually, the courtyard plays a role later, so it's not entirely gratuitous. So it's nice to see it. You'll know what I'm talking about later on. The building. There's a lot I could tell you about the building. The things I'm telling you about here are a very select group of features that have to do with some of the limitations that we had regarding stormwater and an Ecoroof. So the first is that we've got a full, I can look at it on the computer here, full city block building, which means there's really no place to infiltrate. And we had a level of underground parking, which also meant there was no way to get underground and do infiltration there. And then we had 5 stories of wood frame, as I talked about, over a concrete podium. And we had the brick cladding on all 6 floors, as I mentioned. This put an amazing amount of structural focus on this building. We were really reaching the limits of what wood frame construction could do. And you know what we've got there, there's a lot of weight hanging off that wood, and then the thought of putting an Ecoroof on added more weight to the top. So we've got 2 things going on. We've got compression forces, you know, the weight. So we've got to have bigger studs and thicker studs to support all that weight, and bigger foundations and footings. But we also have shear forces. We're trying to resist movement in an earthquake. And putting the weight at the far edges of the building and on top of the building are like the worst places to put it. You know, did you ever have those inflatable punching bags when you're a kid where, you know, you hit them and they come back? They've got all that big sand at the bottom and they're just air above, so you knock them, they always come back upright. If you think about those things and you think about putting some of that weight on the outside of it and on the top of it and you hit it, it's just going to fall over. Well, that's what we're kind of doing with our building. So we put all that brick on the outside and then put an Ecoroof on top. This thing wants to fall over, so we got to do a lot of work inside to resist that movement, that tendency to make it fall over. And we're concerned about it because in an earthquake, which will come sooner or later, there's a lot of people living in that building, and we don't want people to die, so we want to design it so that it, you know, even if it gets some damage, that it stands up and people can get out on time. And hopefully that the brick doesn't collapse onto the street. So the other big limit, so that's, those are some of the limitations. The other big thing is that we're designing this and financing this in 2008 and 2009. And if you were in the development business, you knew that wasn't a really good time to go out and get loans. So not only was it tough to get lenders and investors to answer my phone calls, but even as we got to work with them during the course of the year that we were financing it, the amount of equity that we could get for selling tax credits, this is an affordable housing building, and the amount of the loan we get kept shrinking and shrinking as that market got more and more conservative. And so it was, so that meant it was really tough to spend a dime extra. We were looking for every savings we would get. We weren't looking to spend more money. Not that we ever are, but sometimes we do. But in that time, it was particularly tough. So those are some of the features that also were limitations. So I just wanted to show you real quickly some of the structure that was already built into the building. This is the shear wall down in the garage. And you can see the amount of rebar that goes into that, again, to resist that movement. That shear wall is kind of the base of all of our reinforcement going up through 6 stories. And then the one on the right is the first floor concrete deck. It's called a post-tension deck. So that shows you kind of the amount of rebar and post-tension cables that go into that to make that concrete deck strong enough to resist lateral movement. So there's a lot of reinforcement going into this already. It's tough to think about adding more. Here's some of the framing. This is not a very good shot of the frame, I'm sorry to say, but you can see, you might not be able to see, but trust me, these are 4x6 studs on the walls. We do advanced framing, so we have single top plates. We have blocking here in the hallway, I think to support a hallway ceiling, but we've got all this sheathing on walls. These are the party walls between units. So that's part of the shear wall system. You can see this on the hallway wall, the shear wall systems. On the lower floors, most of those shear walls became double-sided shear walls, and that's a big pain in the butt because you frame those walls up, you put the sheeting on one side, you come back, and then you bolt them all down to the floor, so you're tying everything together vertically, and then you come back and put in the plumbing and electrical and whatever else you need to put in the walls. And then you're bringing the framers back, you know, a couple of days or a couple of weeks or a month later to put more sheathing on that wall and close it up. So it's out of sequence. So the double shear walls, which we needed because of these loads, add cost, but they also add time to the schedule, and schedule for us adds a lot of cost. You know, interest costs on these things are a couple $1,000s a day at the end of the project, so we don't like extra cost. We don't like extra time. So that's kind of some of the stuff we were doing with the building. And there's a look at the hallway. For the first, I think the second, third, and fourth floor, all those corridor walls were double-sided. So we'd do this on the corridor side. Again, bolt everything down, run the tie downs through the building, and then do the plumbing and electric, and then come back after all this was done and put on the other side of the sheathing. So a lot of work, a lot of coordination for the contractor. So stormwater on this, I've always cared about getting the stormwater treated. My first choice is actually infiltration. That's a lot of what Tom and I worked on at this great project at Buckman Heights and Buckman Terrace. We managed to put almost all the stormwater back into the ground. And I kind of like it because, you know, an Ecoroof, it has some advantages, but a lot of the water is going to the stormwater system anyway. So getting it back into the water table, I think, has a lot of advantages. It's less maintenance. It's a whole lot less cost. But like I said, we couldn't do it on this site because there was no place to infiltrate it. So the second choice, you know, and this is let me say, this is when we started our schematic design, probably in the summer of 2008. We got to make these decisions early on which way we're going to go. So we said, well, let's, you know, what about an Ecoroof? The Ecoroof, you know, had two huge cost factors for us. The membrane, the soil, the plants would add about $10 a foot. And then the added structural, we weren't sure, but, you know, we were guessing it was going to add maybe another $160,000 to it. There was no way that we could take extra costs in that climate, that financial climate. So we just wrote that off, really. And then we went to doing detention and mechanical infiltration. So we built a lot of stormwater planters in the courtyard to filter the water, and then we'd have a big detention tank down in the garage that would store the water and then meter it out slowly and filter it on the way. And so that's what we started pricing. This is just to give you a little orientation to the building. So that's that gratuitous photo of the entry you saw earlier. That's 14th Avenue, and that's the courtyard. And you can see we're really covering the whole site, so there's nowhere to do any infiltration. And then this was an early, very optimistic look at the planters. That these planters, we later on realized to do the stormwater treatment in the courtyard that we were going to be required to do, those are going to be 4 feet tall. So this was not going to be an inviting courtyard, despite the best efforts of a good landscape architect. And this gives you a little blow up just to see how much of that courtyard those planters were going to have to cover at 4 feet tall. It was really going to be very tricky to make that an inviting courtyard and a useful courtyard and deal with the stormwater. But that's what we were stuck with because we really couldn't afford anything else, so we figured we'd work it out somehow. But by that fall, BS was putting out maybe its first round of Ecoroof grants. I'm not sure which, but Tom called me up and said, hey, you know, we got these grants available. So we took a look at it. We had the work priced. It came to $531,000 when we added up the roof costs and all the structural, and that meant the grant was going to be about 150, so we had to come up with 360. That wasn't going to work. So we just kept going with our other plan to do the detention infiltration. So there's kind of what our numbers look like. The two big ones, as you can see, were the plantings, the soil, et cetera, for the almost 31,000 feet at $10 a foot, and the added structural cost for the whole building, because we needed to reinforce the structure through all 5 floors below, at about 160. So that's most of the cost right there. We also thought if we're going to do this, we need to put in a leak detection system, which we thought was going to be about $1 a foot up on the roof. So $531,000, toss that out, back to detention and filtration. So meantime, we keep designing this thing. Now we're pretty far along. In March, we've also applied to the city for the Green Investment Fund, which no longer exists. And there was some money from BES in there. And Tom called me up and said, you know, we're not getting any applications in that fund for the BES kind of money. Would you like to go back and look at the Ecoroof again and see if we can get some green investment fund money to help? So we went along. We were much further along in the engineering and pricing by now, so we could come up with more precise numbers. These first ones are really just ballpark estimates by the contractor based on very early schematic designs without much engineering done. So we had to figure out how thick the soil could be. We worked with Tom and the landscape architect, and we realized we could probably do a viable roof, with soil from 3 to 4 inches. We couldn't put much more weight on that. We needed to put some gravel on for pads anyway, and that was a little lighter in saturated soil. And when we priced it all out, we got it down to about a little more than a little less than $8 a foot, and with the $5 a foot grant, this is now kind of viable. So the added cost, I'll show you these in a minute, we were about $338,000. We had extra engineering design because by now we'd engineered the first system and we had to go back and re-engineer, and we had designed the courtyard, we had to go back and redesign the courtyard. And so we had costs that we wouldn't have incurred if we'd been able to do this in the beginning, but we had to factor those in. But these courtyard planners, as I said, had gotten a whole lot bigger than we thought they were going to be. So being able to get rid of them represented a much bigger savings than it would have originally represented. So we decided to go ahead with it. Then here's what the cost looked like in 2009. The added cost, we got 200. So we realized we'd priced $31,000 before, but $5,000, that's going to be the gravel and the walking surfaces. So the planning was only about a little more than $25,000. And our bids were getting pretty good. The good news about 2009 was construction costs were a lot lower. That was about the only good news, but it was important good news. So the ballast cost, we got to $3,000. We've got the roofing membrane was a little more expensive. So you add that up, you got 226, about 230,000 really for the green roof, and about 50,000 for the structural stuff. And the leak detection system cost had come down from our estimated 30 to 17,000. So prices looked a lot better. So we were adding about 338. But the important part was these massive stormwater planters were going away, and the detention tank in the garage was going away, and waterproofing. And so the savings had grown in some ways because that detention and filtration system had become a little more expensive than we'd originally thought. So here's kind of a summary of it. We had really the net added cost with the engineering thrown in was about $235,000. We were now able to get about $200,000 in grants, we hoped. And so the net cost us was only $28,000. That was manageable. But with that detention tank, we were also going to have an annual maintenance call down there to get a big truck in the garage to clean that thing out and change the filters and whatever they're doing. We'd been estimating about $4,000 a year. So really, we had an instant payback after some big grants of 7 years. Well, that was a pretty simple decision to make. So we went ahead and did, but I got to tell you, there's some unanticipated costs. There always are, right? Redesigning the courtyard and the design and the construction probably added a whole lot more. And it was actually hard to track how much more added cost we got to because we made the the courtyard into stormwater filtration also. But it could have been as much as $30,000. I'm really just ballparking that. The irrigation for the Ecoroof last summer was pretty darn expensive. We're not quite sure. I was just talking to Tom. We have sub-meters on the system, so we'll be able to track it this summer. But the first year, we put a lot of water up there on the roof. We're hoping that by the third year, there's very little irrigation going onto that roof once it's established. But it could have been as much as $1,500 extra per month. I looked at our bills during the summer, and I looked at our bills the rest of the winter and kind of took out the average. Because it's not just the water, because we're also paying sewer charges for that water. If you do this in your house, you don't get charged sewer in the summertime. Unless you buy a separate meter and pay this extra monthly charge with BES, you're going to get charged sewer for irrigation this summer on a commercial building. So it might have been cheaper for us to go to the extra meter and the extra service from BES, which they would charge us year-round, even when we weren't using the irrigation meter. But we'll find out. So, if I add up 2 years of that kind of stuff, that could be another $9,000 if that's really what it's costing me before we start to really cut the irrigation back. So I don't have great numbers on that, but we know it's higher. One thing I didn't budget for was the higher cost of the landscape maintenance contract. And, normally we've got about 5,000 feet of planning in our courtyards around the edges and very little landscape maintenance. Now we've got 30,000 feet that we're, reading pretty seriously for a couple of years. And so, we got a bigger monthly contract from our landscape contractor. We're just getting priced on that, so Again, I don't have exact answers, but it adds up. So there's some extra expenses that we incurred we probably didn't factor in. And this leak detection system, I don't know if you're familiar with these, but if we ever have a leak, it's hard to find in the roof because it always comes out at the low spot of the roof. It comes out below at the lowest spot, but it doesn't mean that's where it actually started. So we've got this wire mesh down. But if we ever want to use it, we've got to call this contractor back to hook up their wires and their scopes, and it's like $1,500 every time they come out. So we're probably never going to use it because the roof's never going to leak. But I'm just trying to say, there are extra costs along with this stuff that we didn't anticipate, but there's also probably some savings. We don't expect many repairs of the roof because this is one bulletproof roof membrane. It's not going to get heat and cold on it, and it's not going to have maintenance guys walking around on it. And I think a lot of them go up there with their golf shoes on. And I think they'll all come up. I mean, 6 years later on my last building, every time I go up, I come back with a pocket full of hardware because it just appears. And I don't think it's the birds bringing it up. I mean, I don't know what they do up there, but it's like crap all over the roof, screws and washers and metal shavings. It's incredible. And you got to pick it up because otherwise it gets ground into your built-up membrane and you got leaks, which we hate. So we're not going to have that on this roof because it's covered. It's really great. So, we also have PV panels and solar hot water on the roof. And the PV panels, I think, operate maximum efficiency at about a 77 or 78 degree Fahrenheit ambient temperature. So if you've got a conventional built-up roof on there, your ambient temperature, 2 feet off the roof is usually in the summer 120 degrees or something. This is going to be a lot cooler because of the plantings around there. So we might be getting more efficiency out of these, but unless we'd done another building without the Ecoroof and the same panels, we really can't measure how much difference. But we suspect we'll do better. We've got big makeup air units on the roof. They're taking in air in the summertime for cooling, and that's going to be moderated again by the cooler ambient air temperature around it. We don't know how much, so that's probably helped. The tenants on the 6th floor of the building pay their own heat. They're probably going to have a little more insulation on the roof, but not a lot in the winter because wet dirt's not a great insulator. I mean, we'd be packing it in our walls if it was. It's not bad in the summer probably, but it's not so good in the winter. But we do have a drainage mat, so there's a little air space, and we optimistically assess that would have about an R1 value to the roof, so it's nothing to sneeze at. But anyway, so and then the capital cost. This roof could last 100 years. Nobody knows because they haven't been around long enough, but it's a great membrane. It's way better than we'd normally put on, and then it's protected from everything that could harm it that we know of. So there's other things to think about besides that first analysis I showed you. So here's the roof itself. Now let's get to the fun part. This was a sketch we did because this thing was so darn confusing, and you got to remember we added this when we were pretty far along. And everybody's going to know, what are we putting on there and what sequence and how do the drawings work? So this is like a sketch the architect did. So we got the plywood sheathing on the roof. We got a vapor retarder that we put on there because we wanted to protect it from any rain and moisture before we got the rest of the stuff down. That's really not part of an Ecoroof. Then we got rigid insulation on top of that, 2 layers. That has a cover board on it. This is wrong. Then the leak detection layer goes in there. And then we have our roof membrane. And then there's a protection cover on that because we couldn't put the dirt down right away because we didn't want to get compacted because other people were still working up there for months. And that couldn't be exposed to UV for too long, so that had its own protection cover on the membrane. And then we get a root barrier down just in case those little plants try and sneak through all this stuff. And then you got some drain mat, and then a filter fabric on that to keep the dirt from getting into the drain mat. And then you got the dirt, and then you got the plants. So there's a lot of layers, but there's also a lot of coordination for the contractor trying to think about, which ones you put down, when you have to stop to get something else going on before you can get back, and how do you have to protect those intermittent layers in the meantime. So we needed that kind of roadmap for ourselves, and so here's what it looks like. So show you some of the layers. So plywood deck, obviously. These 3x10s are not part of Ecoroof. They're the structural attachment for all of our solar hot water and PV panels. We had to find some way to put those on the roof. We didn't want to penetrate through the roof with all those tie downs. So what we did was we reinforced our roof trusses, bolted these 3x10s down everywhere, and then we could bolt our equipment down to that so we didn't have a path for water to get through. So that's our vapor retarder that we put down, mopped on kind of stuff, so we could protect the plywood until everything else went on. Those are the tie downs for the tie-offs for our roof, for our window cleaning guys. Then, so there we are where we left off with the vapor retarder down there. Then the insulation goes down, 2 layers, and you can see it butts up against those 3x10s, and then the second layer covers that up. So there's, I don't know, these are 6 inches of rigid insulation. It's pretty good. And then there's the protection board on that. But first, the leak detection fabric goes down. This metal fabric goes down, and they can test that and find, where there's a break in that electrical field that the leak comes through. So, and then you can see the membrane, the very first part of the membrane starting to go down, rolling down. It's a torch down system. So those are the next couple layers of roof. These then are the stanchions that the solar stuff is bolted onto, and they're bolted on, as I said, onto the 3x10s. So we get it kind of up above the lowest spot of the roof for leaks. There's a nice guy torching it down. I've got some, so we can actually see the flame shooting out. You can't see the flame shooting out of this one, but there's a flame shooting out. But that's how these torch down things go on. So there's that protection board on the insulation. There's the membrane being rolled out. And then you can see wherever we put those stanchions through, we sealed the living daylights out of that thing, wrapped it around the roof in a big 12 by 12 area. And then you can barely see it here. I can see it. You probably can't. We took it up about 6 or 8 inches, that same kind of sealant, because all this stuff is going to be covered with dirt, and we didn't want any. I mean, this is where you get leaks. You get leaks at penetrations and at joints, really, not out in the middle of the field. So these were our weak spots. They're sitting on top of the 3x10, but they're still weak spots, so we covered them up. And then this is the drain mat in big rolls that it's about to go down. There's some of our air handling equipment. And so there's the protection course on top of the roof membrane now. This is the stuff that protected it from UV for a while, so we had that down. Then the roof barrier goes down, and then that's the combination drain mat and filter fabric on top of that. And this, of course, is dirt. What you don't see on this roof, I'm going to point it out, is what you'd see on a lot of buildings like this, you don't see the little mushroom fans that are the fans for the bathroom exhaust. Most of these mid-rise buildings have continuous exhaust fans in the bathroom, and there's a little mushroom fan about every 20 or 30 feet that sucks it out from 5 floors. We got rid of those because we wanted to do some heat recovery stuff. So all of that duct work for all those is running horizontally in the attic and feeding those big air handling units. So it was an energy efficiency thing, but it also turned out to be a nice decision. Once we put the Ecoroof on, it gave us about 50 less penetrations in that roof that we had to worry about, and also looks better. So loading the soil, this is fun. I had a better shot somewhere, but I couldn't find it. These guys would run along with their utility knife under the bag and kind of slice it and get out of the way as the dirt dumped out. But what this shows you, the reason this is here, is it shows you that this isn't just floating up there. There's a crane holding it up. And the reason that's important is it's another cost. By this stage of the job, the construction crane is usually gone. We don't need it anymore. So you really had to sometimes, either keep the crane longer, and that crane costs us about $20,000 a month. So we don't want to keep it longer, because what don't we like? We don't like costs, right? Or we've got to get the dirt up there out of sequence. And so, really you'd want to get all the mechanical work done and everything else done on the roof before the dirt went up, all the solar stuff installed, but you can't, because you got to get the dirt up there with a crane, or getting the dirt up is going to be a whole lot more expensive because they're not going to take it up the elevator. And then you get a mobile crane out there. So it's that bouncing of the schedule and the cost to try and make this thing work right. And these are some of the things we didn't fully anticipate as we made these decisions. Spreading the soil, even though we got it spread out pretty good with the crane, by that point, the crane couldn't reach everywhere because the building was finished and the sheet metal was on it. So there was a lot of wheelbarrow work going up there. I don't know if you can see, we kind of had paths laid out. This doesn't show very well. But anyway, that's spreading the dirt. And so this is it's installed. You can see the first plants are up there. And you can see the crane, which used to be parked out here, is gone. So that meant those probably went up the elevator, which takes a long time to get 30,000 feet of planting material up and down an elevator. And the elevator doesn't go to the roof, so they come out a little hatch at the end. It was really dirty in there. There's extra cleaning cost. Here's what it looked like when we first planted. It's not really that pastoral yet. But here's what it looks like today. So you can see we experimented with lots of plants, and they're growing pretty well. We put this in, I think, February or March last year. And some of it got going during the summer, and then this spring it's doing great. One of the problems we had was we were feeding the crows a lot. You can see these little root balls are out everywhere. We used pots for starters instead of cuttings on the roof. And we kind of debated it. And Tom and I actually had this conversation before we planted the roof. And you know, Tom was saying, we had this project where we had to go out every morning and put the plants back because the crows would find the insects in the root balls, pull them up, take the insects out, but they wouldn't put them back. You know, so I mean, they're smart enough. They could put them back, really, but they don't. And actually, they were doing this when we had the plants stocked on the roof, still in their little plastic things. So I think the young crows, the teenagers, would throw the pots out onto the street. So we're finding little pots on the street. I don't think the adults did that. It's probably mostly the boy crows, the girls, I don't know. But we spent a couple months putting the plants back. So you know, when Tom brought this up, I said, well, crap, why are we putting plants, you know, pots up there? Why don't we use cuttings, you know? Oh, good. So we actually went back and we bid cuttings. But this was now in construction in 2010, I guess, and it was shocking because the cuttings, which you'd think would be really cheap because they don't have to grow them and they just throw them out there, cost us probably twice as much as the pots because we'd got such a screaming good deal in 2009 on the pots. So it became more expensive to add a change order to go to the cheaper material. So we stuck with the pots, but that meant that we fed the crows a lot. And mostly that stopped, though it's not 100% stopped. I was up there last week and there were still a few plants pulled out. But I think the insects are mostly gone. And that's tough to manage. Insects go in the dirt, I guess. This was a shot from 7 months apart of it. This was a little more pastoral. It looked great. I think that was last November. And this is what the redesigned courtyard looked like, what we were able to do once we got those 4-foot-tall planters out. This whole area is raised, and these planters along the edge become stormwater filtration. And these are stormwater filtration, and it all feeds into a big layer of sand underneath here where it eventually gets filtered before it goes into some drains into the storm system. So we did a lot of, with BS's help and our landscape architect, did a wonderful, both functional and totally aesthetic courtyard. It was functional, I guess, in terms of stormwater treatment, but also functional in terms of how tenants used it. You know, the raised area created a nice lower feeling walkway. There's a curving walkway that goes around that gives us a bigger uninterrupted play area. This is housing for families, so the playground was real important. And so it turned out great. And that's my story, I think. That's the end.
So you might have lots of questions. Maybe we only have time for one or two. Any questions? He's that thorough, isn't he?
Or that confusing. Thank you very much.
So our next speaker is Renee Loveland, and